Okay, boys, so my latest attempt at doing something on YouTube is actually going to be concerning itself with mass airflow sensing. In particular, the hot wire type mass airflow sensor. Why hot wire? Because that's the type my car uses. So kind of doing some studying on it, getting familiar with it, and I've checked out some of the other material that's on YouTube. There's plenty of other efforts out there describing the theory of operation and the workings behind mass airflow sensors, but to be honest, I thought most of them were kind of scant on details. Some of them are very good. Some of them will be far better than my effort here. I don't want to come across as knocking anybody else's efforts, because it's not easy to do that stuff, believe me. I'm going to do this as a three-part series. Part one will be the concept behind mass airflow sensing. Part two will take a look at in depth at the circuit design and operation, and part three will look at some testing and the physical installation on the vehicle itself. So I thought I'd draw up this little concept drawing. I haven't seen it anywhere. It's just something I kind of came up with, and hopefully it gets a point across. So what this little circuit consists of is basically a DC supply voltage that is applied across a heating element, and we have a rheostat in order to control the amount of current across the heating element. We also have a fan, which is actually applying cooling air across the heating element. So let's actually set everything to the mid settings. We'll turn the system on, and what we're trying to do is maintain a target temperature of 100 degrees at this heating element. That's why we have a temp sensor actually monitoring the temperature, so we can actually set everything to get that 100 degree point. We also have a voltmeter monitoring the voltage drop across these two elements of the rheostat itself. So as I said, we'll turn the system on, and we'll set the rheostat so that we get enough current going through this heating element that with this set volume of air going across whatever it is, that will actually maintain 100 degrees at the heating element that we can actually note on the temp sensor. So we know the temperature is 100 degrees, and we can note the voltage drop at the rheostat at that particular point in time. Then in the lab, what we can do is we can actually establish what the mass of air is that actually is flowing across this heating element, and actually record it onto a data set so that we can correlate the flow with the voltage drop across the two elements of the rheostat, as I said. So by doing that, now we can turn up the fan speed. There'll be a higher cooling effect on the heating element itself. And then we can actually turn down the rheostat in order to get more current through the heating element. Again, that will be reflected in the voltage drop at the meter. And so until we get that 100 degree temperature, we can then take a measurement in the mass airflow that is actually going across the heating element, again at that target temperature of 100 degrees. And again, we could once again plot that data in a matrix or lookup table, right? So this would all be within the engine control module, ready for reference in reality. Could then take a voltage reading from the mass airflow meter, and then be able to correlate this with a flow that's actually going through the engine. Why do we actually require mass airflow sensing of any type? Well, as anybody who's familiar with any kind of study in automotive design or systems at all, 14.7 to 1 air to fuel ratio is the magic number with respect to automotive carburation, or of course fuel injection systems in a modern car. And if we're going to maintain that ratio, what we can do, we can modulate the pulse width on the fuel injectors in order to meter our fuel. Fuel's kept at a set pressure, generally speaking. So by simply modulating the pulse width of the fuel injectors, we can control our fuel tightly. But what's the point in controlling the fuel tightly if you can't actually measure your the amount of air that's going through the engine, that's being utilized by the engine itself? So this is where the mass airflow sensor actually. Okay, boys, so I guess I'll leave it at that. So this is a wee bit esoteric subject, mass airflow sensing, especially when you consider that in order to measure the volume, or more accurately put, the mass of air that's actually going through the engine, you're actually utilizing a heating element and a voltage drop within a bridge setup, a bridge circuit. This is a simplified version of how things are done. In reality, it's a bridge circuit. It's a wee bit of an esoteric concept to actually come to grips with. It's no easy. As I said, this is going to be a wee bit in a deep dive. So hopefully this little starter point actually has tweaked your interest, and you can stay with me for the rest of the program. So I hope that makes some sense, boys. Okay, that's it, boys. See you in part 2. Cheers.